Let's go over a couple more examples so it's more clear where the import policy and the export policies are applied. So this is the same example we saw earlier. Destination network is here, X, okay? And so AS3 there is gonna send the pass advertisement. Okay, that looks like this, AS3, comma, X. Okay? And this is gonna reach 2C of AS2. So AS2's router 2C receives pass advertisements like this. And this is through the exterior BGP connection. And the advertisement came from AS3 and from router 3A. So 3A of AS3. Now, if you recall in the very early slide, right? The border router here will then propagate the AS path throughout all routers in the network. But no, there's import policy. So the exact process is more like this. 2C there will actually check AS2's import policy. If the policy says 2C, it's okay to accept the pass, then 2C propagates the pass to all routers internal of AS2. Okay. So sending of these AS pass internally is through the interior BGP connections. All right. So the import policy actually happens before the propagation of the pass, okay, to all the routers internally. And then, 2A here, receiving such a pass, can then prepend itself and pass it further to the neighboring ASs. But wait, the export policy is applied here before passing on of the advertisements. Let's check. If 2A here is allowed to advertise the discovered pass to AS1 here, then we form the new advertisement AS2, AS3, and X, and then send it to 1C that belongs to AS1. Okay, so once again, before the prepended, the extended AS pass can be advertised further to the rest of the internet, we check the export policy. Right? Second example is a bit more realistic. So 3A here, the gateway router of AS3 might have multiple eBGP connections to outside. Okay, so in that case, a gateway router might learn multiple paths to a destination in AS3. So let's see. One of the paths is this, right? AS3's 3A sends AS3X as an advertisement to 2C. 2C checks the import policy and therefore pass it on to all the routers internally. 2A picks it up, checks the export policy, and let's say that it's just allowing advertisements of the pass further. So prepend AS2 to the pass and then send it further. At this point, 1C learns the pass AS2, AS3 to destination X. And the way to go is for 1C to send to 2A. The other direction is this. 3A can be simply sending what? AS3X, this past advertisements directly to 1C. And 1C will just simply learn, right? There's another way to reach destination X, which is just simply sending it to AS3 through 3A. Okay, so these are the gateway border routers that 1C send the packets to, for the two different paths, 2A and 3A. At this point, 1C sees two advertisements coming in. Before 1C propagates any of the paths further, it needs to check the import policy. So AS1's gateway router 1C there, we need to choose. It could choose one of the two, or it could just take both of them. Let's say that 1C chooses AS3, X. The shortest AS path. and advertise it to all routers internally of AS1. Okay. This is the second example. Let me borrow example 2 here and continue to talk about this. How a router sets up a forwarding table entry, okay, for a destination outside of the AS. Okay. Yeah, scenario the same, destination being X. 3A, the gateway router of AS3 has 2 eBGP connections, therefore 1C here potentially can receive 2 AS paths. And 1C, according to example 2, chooses the shorter AS path. So let me run the animation. So 1C discovers 2 paths and picks the shorter path. Okay. And this shorter path is further propagated internally to all routers. So 1A, 1B, and 1D will learn about the shortest path to destination X from 1C. And what 1A, 1B, and 1D will do is, well, if I receive ever any packets with destination X, then I will forward the packet towards 1C. The border router, okay, they receive, okay, the AS path from. Okay. Now, to make it easier to explain what's coming up next, let me just label, okay, for 1A, if the packet is supposed to go out on this interface, then we call that interface 1. And yeah, for packets to go out on this other interface, let's call it 2. Okay, similarly for 1D, this is interface 1, this is interface 2. Now, 1D here, okay, has discovered there is a path to destination X that is going through 1C. Okay, that is what 1D knows so far. To add an entry into the forwarding table for X, 1D needs to know exactly which interface, is it 1 or 2, that leads to 1C. How would 1D know that? Call the intra-AS routing there. Okay, let's say it's OSPF. Okay, so OSPF is going to tell us if the destination is 1C, what is the link along the shortest path to 1C. Okay, so that happens to be 1, so we will fill this entry here, okay, interface column being 1. Similarly, let's try to derive again for 1A. Okay, so 1A knows, for destination X, I should be forwarding packet towards router 1C. So let's call intra-AS routing and find out from OSPF, what is the shortest path to 1C and which link, is it 1 or 2 on the shortest path? And we'll get 2 here, and 2 here would forward packets to 1D, and 1D here we see earlier will be forwarding packets over this direction and reaching 1C. Therefore, going backwards and reaching destination X. Route selection. Now, this mechanism is necessary for slightly more complicated scenarios. Let's go back to example 2 again. Right? We have this router, 1C, being the gateway router of AS1. So you see towards the end of the scenario, AS1 discovers 2 AS paths. One from AS3, to go to destination X. The other from AS2, and then via AS3 to go to destination X. So in the previous slide, we say the policy of AS1 is such that we only select this to import. And so 1C propagates this AS path to all internal routers. Internal routers will then send packets, destination being X, through 1C and therefore being forwarded to AS3. Very simple. But what if we relax the import policy a little bit further so that 1C here cannot discard this other AS path? As a result, 1C will need to propagate both paths internally. So each of these routers internally will see more than one route to the destination X. Yeah, so that's when we apply the route selection. So internal router there will need to apply route selection here to decide which of these two, okay, it will send packets to. The process is like this. Step number 1, check the local preference of these routes. So if you recall earlier, a route, okay, is what? Composed of the destination network's prefix and a set of these attributes. So we know that ASPath is one attribute. Next hop is one attribute. There's one more attribute called the local preference. Okay, so this one actually weighs the highest. Okay, so BGP actually checks the local preference first and take the path with the highest local preference. Okay, so local preference there is usually to indicate, yeah, between the two neighboring ASs, AS3 versus AS2, does AS1 prefer forwarding packets to AS3 or AS2? So if AS3 is preferred, AS3's path, so this guy here is going to carry a higher local preference. Okay. Now, if there's no local preference specified, then we go to step 2. So the internal router, let's say 1D here, okay, will then check which of these multiple paths to destination X give us the shortest AS path. So in the scenario, 1D is going to pick this one. Okay. Now, if both AS paths have the same path lengths, then we go to step 3. We pick the closest next hop router. Okay. Yeah, 1D here sees 2 paths. Okay. The next hop router for this path is going to be 1C. The next hop router for this path here is going to be 1C as well, because 1C is the border router, okay, receiving, okay, these advertisements. But if you consider, okay, a slightly different scenario, okay, so again we have AS3, AS2, and AS1. Okay. And so the router now in the limma is now 2D. Okay. 2D here actually sees 2 AS paths. One AS path is actually coming from 2C. 2C is the gateway router connecting to AS3, okay, which it receives a path to X, AS3, X. 2A is the gateway router connecting to AS1, where AS1 is passing another AS path, okay, to AS2. That is AS1, AS3, and X. So 2A pass this path to 2D. 2C also pass on this path to 2D. Okay, so 2D in the end learns, okay, there's one AS path through next hop 2A, this guy. There's another AS path through 2C, this one. 2D here, okay, assuming that abandon the shortest AS path phase, goes straight to the closest next hop router phase. Then we'll do this. For this path, next hop router is 2A. For this path, next hop router is 2C. 2D here will consult, okay, the intra-AS routing again to find out, is 2A closer or 2C being closer? Okay. So if you see the scenario, 2A distance to 2D is only the link cost between 2A to D, which is 201. Distance between 2D to C, however, is 263. So 2D here is going to choose 2A to forward the packets to. So it's going to choose AS1, AS3, and X, this other AS path, which is actually longer, okay, than this other one to pass the data. This is also very well known as the hot potato routing. Allow me to explain. Yeah, so 2D is this guy holding a hot potato. So yeah, the packets are almost like these hot potatoes. And 2D can't wait to get rid of these packets. So 2D wants to be able to pass the hot potatoes, the packets, as soon as possible. Therefore, picking this poor guy here, 2A, to throw all the hot potatoes over. Okay, distance is shorter.